Hi everyone. Now we want to share a little bit more of the introductions to data mining using Pandas. So many of people will kind of stick around the world of using Pandas, but in about October 2017 alone, Stack Overflow, a website for programmers, recorded about 5 million visits to questions about Pandas and more than 1 million unique visitors. Data scientists at Google, Facebook, JP Morgan, and virtually every other major company that analyze the data uses Panda. So most people haven't heard of it, but many people do heavy data analysis, rapid growing groups that of these days, and life wouldn't be there without it. So Panda is open source, so it's free. Yeah. Development of Pandas with Wes McKinney hates the idea of researchers wasting their time and scientists unnecessarily dealing with drudgery of sample data manipulating the task makes him feel very terrible. So that's what he says. So you still have to write the codes, but the codes intuitive and accessible helps the people to move beyond just using Excel for data analysis. So basically Pandas make it so that the data analysis task that would takes about 50 complex lines of codes in the past now can take about 5 simple lines. So because of McKinney already did the heavy lifting. So with that, uh, pandas and some of the data structures just want to share. So Panda series and Panda data frame, the series and data frame that are data structures each contain another pandas data, so it's called an index. Pandas functions to read the CSV files into an object of the data frame class. So the methods of the data frame performs actions on the data frame like dropping columns or calculating this summary statistics. So Pandas series is one-dimensional label arrays like object containing a sequence of values in supporting many data type or similar type of NumPy types, which are kind of shared in the earlier lecture. Associate arrays of data labels is called index. So in objects like PD series 3, 5, minus 9, minus 5, minus 5, 9, those are a PD series, which is a Panda series. In which is the input is the objective and then output what do we get. So the output of the values, right, will be in terms of the array, which is 3, 5, minus 9, minus 5 and 9. The second objective what we can do is the Panda series 3, 5, minus 5, 9, and the index could be DBAC, which actually links to that. So objective 2 and what could be the output? The output could be DBAC and the data type could be object. So we can actually use the array and kind of have that particular index. So with that, the common series attributes to pandas is the name, which is the name of the series of the object, the D type, which is the data type of the series of the object, the shape, which is the dimension of the series object in a tubular form, and the number of rows, and index is the index object that is part of the series object. Values is the data of the series object. So this can be found in the Panda findata.org. So you can actually find this is a series of the attributes. So with that indexing, there's additional of the index class that makes a series significantly more powerful than a NumPy array. The index class gives us rows that a date that even have a string which is now selected by rows. So its key role is to identify the entries of the data in place where underscore and the place of index. In the in, which is the input, could be a place of index, and the output could be the range of the index starting from 0, you stop at 5, and step 1, meaning you say you start from 0, you stop at 5 in the incremental steps of 1. So that's indexing. So common use index could be a name, which is the name of the index object, D type, which is the data type of the index object, shape is the dimension of the index object, and values is the data of the series of the object. It's unique. You check if the index object has all the unique values. So with that, there is some data frame, and the data frame class builds upon series class and it can have many columns with its own data type. The first column of the index object for rows and the time column could be made of index. When creating a data frame index, Pandas align the series to the same index. You say the first line is 0, then you have your date and time, and then of course a place, and then the type of it. Yeah, look like the MWW, and the MAC is 6.7, alert screen tsunami is 1. So you actually has this data frame which actually Pandas align all the series to the same index. So with that, commonly used data frame attributes to the attributes like D type, which is the data type of each column, shape, which is the dimension of the data frame in the tuple form, index is the index shape along the rows and data frame, columns is the name of the columns, and values is the data in the data frame column. Check is basically check if there is a data frame object is empty. So with that, Pandas we consider as a fixed length ordered DICT as it mapped into the index value of the data values. It contains in a Python dict, yeah, which can be passed to a series. Yeah, it's just like a ordered dictionaries. In constants like for example, Bukit Batok 23000 Hougang 2500 East Coast 125000 Marine Parade 13000. So those are like in the constants, and the input of the data could be a PD, a Panda series constant. So in a car inventory, you can actually also name like spark plug 2300, brake pads 2500. So it's very similar kind of a database which considered as a fixed length. So with that, the data frame is a 2D data frame. It creates an area of data, contains an order collection of columns in which it can be different values type, which is numeric, string, or boolean. It has a rows and column index which can be thought as a which is a dictionary of a series and sharing the same index itself. So with that, the data frame in data, you can have a constant, right, which is like East Coast, East Coast, East Coast, West Coast, West Coast, West Coast, and then year 2001, 2002, 2003, and of course the third the number 3 column, right, because the first one is 0, 1, 2, 3, can be 2001, so it kind of aligned to like West Coast. And then the pop is basically something that is related to the data, so you see there's 6 of them, and this actually forms the data frame. So in frame, input could be a frame equals to the Pandas data frame data, and in is the frame. So the index is assigned automatically with the data series, and the column are placed in sort of order. So in frame, it has a head, which is a header. So with that, it converts to a single series into a data frame object. So when you have the data frame, you're actually then able to kind of use the data dump and then put it in the database or website, right? So a type of data dump could be a text file, which is a txt, or Pandas could read commands like read underscore txt and then bracket, which you have the text inside. So Pandas write commands, for example, to underscore text bracket. So this is basically how Pandas can write a command. CSV files, you can read a CSV file underscore CSV close bracket, and then you can actually have a sequence SEP equals to open open colon, and this could be the Panda. This could be how you read from the Pandas. And of course, to write the Pandas command to CSV file, you can output.csv and index equals to false. So an Excel, you can read the Excel in terms of the data in the Excel. So you can actually read from this Excel file. Then when you want to write a command, you can actually write to the Excel. A JSON, which is a JavaScript object notation, JavaScript object notation file, which is .json. You can actually read a JSON file and read underscore JSON bracket. Those inside are your data. And then if you want to write a command to the JSON file, is to underscore JSON. So in a way that the data dump can be read using this command for when you're using Pandas, and then when you are writing the command, you can actually use as mentioned. So the preceding files path to read from and read to were relative to our current directory. So you use a current directory where we are running in our codes from. Is an absolute path where it will be a full path to the file itself. So with that, getting data files with request. So request is not part of Python standard library, but it's part of the Anaconda package using the pip command to install request. The get methods of all requests is used to get the page by convention, assign the results to a response object. Response equals to request get. For example, HTTP, Wikipedia, and Nobel Prize. So this is the response that you can actually get. So the status of response could be a response.status underscore code. So HTTP code could be like 200, which is okay. 401 unauthorized, attempt unauthorized access. 400 is a bad request, trying to access the web server incorrectly. 404 is forbidden, similar to 401 is unauthorized. 44 is actually not found, trying to access the web page but it doesn't exist. 500 is an internal server error, a general purpose called catch-all error. So HTTP status code can be actually stated inside. A lot of time we see the 404, which is not found, and trying to access the web page that doesn't exist. So with that, Panda data cleaning. The real reasons that the real world data is messy, right? And what we want to do is basically to clean the data for analysis, and methods of Pandas provide methods for cleaning the data. So with that, because the data is messy, there's missing value, outlier, invalid data like negative of age or height, NaN data or non-value. Little or no control of how data is collected, but the data cleaning involves detection and correction of this messy data. So in a real world, the data is messy. How we want to do that is to clean the data. So some strategy for cleaning the data, like missing data, you interpolate based on the domain knowledge, and then you delete them if there is not many of them. Use of means, right? Outliers you may want to drop off depending on the situation, and identify investigation if there's any flaw. Invalid data you can replace inappropriate or appropriate values that is based on domain knowledge, and you remove those if there are not as many. So with that, indexing, selection, and filtering, a series of index works and analogously to NumPy array indexing. So use the index value of series instead of only integer. So df define Panda data frame, MP arrange 16, you reshape 6 to 6. So you can actually index it like East Coast, West Coast, Jurong, Potong Pasir as part of the index, and then the column could be 1, 2, 3, 4. So you can actually index and then select and filter those. So with that, indexing option with a data frame type could be a DF data frame, right? VAL, which is a single column or sequence of column from the data frame. Special case convenience like Boolean, array, filter rows, slice rows, or Boolean data frame set values among the some criteria. Data frame local val, which selects a single rows or subsets of row from data frame by label. Data frame LC is actually selects a single column or sub set of a column by the label. Data frame of LOC, alright, which has value 1, value 2, select both rows and column by label. Data frame of ILOC, where select single rows or sub rows of rows from a data frame by integer position. DF ILC is you can column and you column comma where single column or subset of the column by integer position. df ilog where underscore I where underscore j select both rows and column by integer position. df add, you can have a label I and label j where you select a single scalar value by rows and column label. At df label I and label j, you select a single scalar value by rows column position by an integer. So that is basically define underscore I. So this is how indexing option and data frame can actually work on. So missing data. So Pandas uses float values, points, value like a, not a number, to represent missing numeric data. A, NaN as central value is easily detected. So Pandas provide the method is now to check for missing data. So very similar to Excel, it uses is now to check for missing data. So with that, NA handles methods in Panda. Drop is basically filter axis label on whether the values for each label have missing data with variable threshold on how much missing data to tolerate. Funa is basically you fill in the missing data with some value of using interpolated methods such as ffill or bfill. Now is you return the boolean value indicating which value are missing or not applicable. Not now is is negation of is now. So it's a negation of the is now. So is now is return to a boolean indicating the value is missing. Not now is basically not returning the boolean values. So this is how MP right handles the methods in Pandas. So filtering out some missing numbers, dropna is returning to the series only the non-DAO data and index value. In which is data is equals to PD. Pandas data frame like 1.2, 5.6, 3.3, and then the next value could be 1, NA, not applicable, and then this is how the data frame can be found. And then when you input, that's the data. Then you input, you can clean equals to data drop and then open and close bracket. So then it's kind of clean. Yeah. So it's one of the way to filter out missing data. So with that, Funa is basically to fill in the missing data without discarding other data. Funa with constant replacing missing value with that value. So value like scalar value or dark value object to use to fill missing values. So methods like interpolation by default, ffill is function call with no other argument. Axis is axis to fill on, and default axis is equals to 0. In place, which is the argument, is to modify a calling object before producing a copy. Limit is for forward and backward filling. Maximum number of consecutive periods to fill. So descriptive statistics, Pandas objects are equipped with some common mathematical and statistical methods that extract a single value like sum or means from a series or a series of values from the rows and column of a data frame. Yeah, so this is kind of the descriptive values. So method and how we can actually describe it, provide summary statistics that values of various characteristics of the data. And missing data for timestamp. Timestamp specific time instant in time, fixed values such as month, January 2010. Intervals of time indicate by a start and the end of a timestamp itself. So this is the data type for timestamp. Time and date data type. Python's standard library includes data type for date, time, data, as well as calendar related functionality. Date time function stores both date and time down to microseconds. from input could be from date time, import the date time, and input now is equals to date time open and close bracket. So this basically tell us that you can actually input the date and time as is for now. You can also input now dot year, now dot month, or now dot day. Time delta methods represent the temporary difference between two date time object itself. So with that, converting between strings and date time, format date time object and pandas timestamp object as strings using the strings and string time methods. You input, you have a stamp equals to the date time. For example, 2011, comma 1 3. Or input could be a stamp of time, and the output what will become is 2011 January 3rd and at 0 100 hours. Yeah, so you can actually stamp your string, right, ft time into basically a percentage y to month and date. Yeah, so this is how we can actually do. So then when its output is year 2011, month 01, which is January, and then date is 03. So percent y dash percent m dash percent d could actually give us this format itself. So time handling universal time UTC is a current international standard. Time zone are expressed as offset of UTC. In Python, time zone information comes from the third party this Python TZ library. And for details information about Python library, look at the library's documentation. We can actually find more. So with that, time format specification is a ISO C89 compatible. Type, for example, year, right, is percent Y. Big capital Y will be 4-digit year. Small capital Y is 2-digit year, and percentage M is 2-digit month. Percentage D is 2-digit day. Percentage capital H is hours in 24 hours clock. Percentage I is hours in 12 hours clock. Percentage M is 2-digit minutes. Percentage S, capital S is seconds. Percentage W, small w, is a weekday as integer, 0 as Sunday, 6 as Saturday. Then percentage Z is a UTC time, offset as plus HH is hours, MM is a minutes, or minus HHMM. Empty if the time zone is kind of naive. So this is one way to identify the time zone format. So Panda can also read Excel. So you can actually pandas.read underscore Excel, IO sheet, name equals to 0, header is 0, name can be none, index column can be not none, user column can be none, squeeze can be false, D type is a data type can be none, engine equals to none, convert equals to none, true value equals to none. So when you actually put this in, actually Pandas can read the Excel data. So with that, Wes McKinney Python for Data Analysis 2018 or O'Reilly Media INC 1005 is a Galveston Highway North Sebastopol California 95472. So these are some of the references. GitHub can also work on that as a hands-on data analysis with some Pandas second edition. Of course, these are some of the references we actually can kind of work on. Yeah.